Welcome. In this video, we are going to discuss about the previous year NEET question in the year of 1991 in physical chemistry under the topic of some basic concepts in chemistry. Let's discuss the question. The first question is the vapor density of gas is 11.2. The volume occupied by 11.2 gram of the gas at NTP. Basically, what is NTP? NTP means it is nothing but a normal temperature pressure, just like STP. STP is nothing but a standard temperature pressure. In this case, temperature is 0 degree Celsius or else 25, which means standard temperature. Standard temperature, which means it can be a 0 degree Celsius or else 25 degree Celsius. It can be anything, but majority we take 0 degree Celsius as a standard temperature, then 1 bar pressure as a standard pressure. In this NTP, it always requires slightly higher temperature than the standard temperature pressure, which means NTP always have higher temperature than STP. Pressure is same. Pressure is 1 bar, pressure is 1 bar, but temperature is always higher than the STP. This is meant by the NTP. Okay. In this case, they are asking the vapor density of gas is given, the volume occupied by 11.2 gram of gas is asked. This is very simple. Rho is equal to m by v. Okay, rho is equal to m by v. They are asking v, but we don't have m. M is nothing but a volume. Sorry, m is nothing but a mass, but it is not a normal mass. Okay, because in this case, the vapor density is given, not a density. Density is only for liquids. Rho is equal to m by v. This is valid only for liquids. In this case, it is a vapor density. So we need a relationship between the mass and the vapor density. Basically, the relationship is needed. The relationship is nothing but molar mass is equal to 2 multiplied by this vapor density. So 2 multiplied by 11.2, it is nothing but 22.4. 22.4 is nothing but a molar mass. Molar mass and vapor density, the relationship is here. Okay. This is a molar mass. This is a molar mass. We have given mass. 11.2 gram is a given mass. So 11.2 is a given mass. 22.4 is a molar mass. You will get number of moles, right? You will get number of moles as 0.5. If you divide, it will give 0.5. So the 0.5 is a number of moles here. Why I am calculating the moles? Because this is very simple, very simple one. At standard temperature pressure condition or normal temperature pressure condition, 1 mole of a gas, okay, 1 mole of a gas, 1 mole of a gas occupies 22.4 liters. This is standards. In STP and NTP also, these two are same. I am having 0.5 moles. So I am having 0.5 moles. So it will occupy what? 11.2 liters, right? 1 mole occupy 22.4 liters. So 0.5 moles occupy 11.2 liters. This is a way to solve this question because they are asking the volume. But in this case, it is not a liquid. If it is a liquid, we can directly use this formula. This is not a liquid. And also it will give us a vapor density. So we need a relationship between molar mass and density. So I am converting the molar mass and the given mass into number of moles. So 1 mole of gas occupies 22.4 liter. So 0.5 moles occupies 11.2 liter. So this is the answer of this question. Okay, this is a way to solve this question. Okay. Let's discuss the next question. This is a very simple one. The pH of the 0.001 molar HCl solution. It is very simple, which means HCl is dissociated into H plus and Cl minus. 0.001. It is basically nothing but 10 to the power minus 3 of HCl dissociates into 10 to the power minus 3 of H plus, 10 to the power minus 3 of chlorine minus. So the concentration of H plus ion is 10 to the power minus 3. So what is the formula for pH? pH is equal to minus log of H plus ion concentration, right? H plus ion concentration. Okay. So basically the concentration of H plus ion is we find. Okay. Then we are going to solve this. Okay. The concentration of H plus ion is given. So it is nothing but 10 to the power minus 3. So minus log of 10 to the power minus 3. If you solve this, you will get plus 3 because the power is comes before. So minus into minus 3, it is nothing but a plus 3. Then log 10 remaining is log 10. Log 10 value is 1. So minus into minus is plus. So the answer is plus 3. Okay. So the answer is plus 3. For this question, the answer is plus 3. Okay. The next question is also the similar type of question. The pH of the solution is 4. The hydroxide ion concentration of a solution will be what? Okay, this is in the case pH is given, but they are asking the hydroxide ion concentration. This is very simple one, because if you study, if you did study, which means pH and pOH is equal to 14. We have pH, then pOH is equal to 14. Then what is pOH? If you, which means 14, 4 comes over there. Okay, then so basically pOH is equal to 10. If you subtract 14 minus 4, it will give 10. Okay, so what is meant by pOH? pOH is nothing but a minus log of OH ion concentration, which is equal to 10. If you put log on the both sides, or else you need to cancel the log. Basically you need to cancel the log. You need to cancel the log, so you need to take 10 to the power. Before that you can go, which means a minus goes over there. It is like a log OH ion concentration, which means OH minus ion, OH minus ion concentration, which is equal to minus 10. If you find the, which means if you want to find the OH minus ion concentration, you need to take 10 to the power, which means 10 to the power, if you take the 10 to the power, this log get cancelled. So here it is only the OH minus ion concentration. So this is nothing but 10 to the power minus 10. So the answer is 10 to the power minus 10. This is a concentration of hydroxyl ion. This is a way to solve this question. Then okay, this is another type of question. Elements having the different nuclear charges but having the same mass number are called. This is nothing but isotope. Isotope is the answer, but there is a one small change in the definition. Same mass number means it is isotope, but what is meant by different nuclear charges? Nuclear charges, which means nucleus contain proton and neutron. Number of proton or number of electron is nothing but atomic number. Okay, so the nuclear charge is based on the proton, because neutron does not have any charges. Okay, the nuclear charge, different nuclear charge means different count of protons. Different count of protons means it will have different number of atomic numbers. So in different count of atomic numbers. Okay, so atomic number is changing, so mass number is remain same. So this is isotope. Okay, this is another way of representing the isotope in this year of 1991. Okay, this is also a way to define the isotope. Okay, then this is also asked. Molarity is expressed as. What does it mean by molarity? Molarity is very simple. In that year, this is a big question. Molarity is nothing but mole per liter. This is the answer of this question. Molarity is expressed as a mole in liter of the what is called the solvent. Mole of a solute, then liter of solvent. Okay. Then this is a final question. When 7.1 gram of sodium sulfate, molecular mass 142, dissolves in 100 ml of H2O, the molarity of the solution is. Okay. They are asking the molarity. So 7.1 gram of sodium sulfate, which means it is a molar mass is given. So we need to take what is called number of moles, because molarity is nothing but mole per liter. This is a molarity. So in this case, how the definition comes, which is nothing but mole is nothing but given weight divided by equivalent weight. Given weight is 7.1. Equivalent weight is 142. Okay, 7.1 divided by 142. This will give number of moles. So this is divided by liters. Liter is nothing but how much? It is nothing but 100 ml. So we need to take 100 ml. So how it will define? It is nothing but 1000 divided by 100. So there's a basically one formula, which is nothing but to define the molarity in the case of volumetric analysis. We have one definition. Molarity is equal to given weight divided by molecular weight multiplied by 1000 divided by how much we are going to prepare between 100 ml. Which means if you solve this, you will get around 0.5 molar. So the molarity of the solution is 0.5. Okay, this is a way to solve this question. This is one of the fundamental formula.